Let's see if I haven't done these videos in a minute, so let's see if I still got it. Okay, so given a binary array nums, return the maximum length of a contiguous array with equal number of zeros and ones. Okay. Oh, looks like I've already solved it. Okay, so let's see. Inputs is just array, nums, which is array only contains ones and zeros, so that's guaranteed. Size can be 1 to large, so 1 can be an edge case. Note that. Output is just integer, number of, sorry, longest substring, longest subarray, which is an integer. So just longest subarray with equal ones and zeros. Okay, so I thought this could be a this could be a what is it? A sliding window array. I thought this could be a sliding window, but that doesn't seem exactly to be the case because if you have 0 0 1 1 1 1 0 0 0 like this can be a valid subarray, but if we have 2 pointers, that's not exactly valid, because like how do you, if you have this here, then we need to find another one. What's the most, okay, if I were to do it myself, I would go through all of these by myself and then try to find damn, so she's gonna stumping me. Oh, okay, but actually, okay, but no, actually, okay, I have a better idea. So, okay, I think a lot of the problems this whole section week has been a lot of prefix and suffix. So another idea could be you count. So okay, so if we're given this 0 and 1s here, we can have a pointer of like, we can convert all the zeros to negative ones, let's say. So let's say we instead negative 1, negative 1, negative 1, 1, 1, 1, 1, 1, 1, negative 1, negative 1, 1, 1, 1. Okay, so if we were to convert this into so at this point we're at negative 1, at this point we're negative 2, this point negative 3. Okay, cool. But now we're here at negative 2, negative 1. Let's switch spaces here. Okay. Negative 1 here. Okay, so this is like this. Negative 1 like this. And then now this is 0. So I guess this can be... No, okay. Here should be 0. Okay. So then now we can say, okay, from here to here, it's this is the current longest subarray we can find. And then we go back to here. So then this becomes negative 1, negative 2, negative 3, right? So now at this point, the longest equal subarray is it this? No, it should be this. Yeah, it should be the index after, right? Because this makes sense. It's not here, it's the one after, right? So this index right here from here onwards. So, and then this is negative 3, then -2, -2, -1, 0, right? That's 0. So then now you do from here to here. Okay, that sounds good. So what we will do is we have a dictionary, and the key will be the index, no, the value. Let's say the current sum. And then the value would be the index, the lowest index of that sum, right? And so you go through, first you need to swap logic here. Let's do, logic is swap all zeros to ones, negative ones. Then go through array and have current sum and calculate current sum. We can initialize init -1. A sum of 0 is indexed at -1, right? Because that's what we want to initialize right here. And then go through array, calculate the current sum. And then if that current sum is not in the dictionary, set it. Else take the difference of the dictionary at current sum, that plus 1. So the current index minus this. And then, well, I guess, because this is 1, this is index 1, and this is index 0. Well, this is index 0. So key, okay, so 0, 1, 2, 3, 4, 5. So yeah, okay, that makes sense, I think. Wait, no, it should be this, because this should be okay, I think okay, I'll say difference and compare this to output. Okay, that's pretty much it. So let's do this. So for I in range of length of nums, if nums of I is equal to 0, nums of I is equal to -1. Okay, and then we have a dictionary of some index, and some index at some 0 points to -1, and then for I, and then current sum is equal to 0, and then output is equal to 0. Okay, so yeah. For I in range of length of nums, current sum is equal to is plus equals nums at I. If current sum is not in some index at current sum is equal to the current index, I believe, right? Yeah, I think so. Else we can verify this. We can make a note of this. Verify. Else the difference is I minus some index at current sum. and then output is equal to the max of output and diff, right? And then you return output. I guess we can do away with this. We can change it here if this, but we can fix we can fix that later. Don't need this. Can swap val at 43. But let's go through this as if we have it. So sum index is 0, -1, and then let's go here. So 0, -1, and then we have at index at sum -1 is at 0, and then now we see 0 at this point, and then that's at index 1. So 1 minus that is 0. Okay, that's valid. And if we do this, that'd be the same thing. Well, okay, so let's do this 0 and then. And we go back to -1, and that is at index of 2, right? 0, 1, 2. Yeah, okay. Now if we were to do this one that I had, this example that I had here, well now we could do 0, 1. Yeah, okay. So 0 is at -1, -1 is at 0, -2 is at 1, -3 is at 2. But then now we get back to -2 is at okay, so yeah, so -2 is equal to -2 is equal to this right here. That's at index 4. No, -2 is equal to 0, 1, 2, 3, right? So that makes sense because -2 is here. So then, okay, I think this makes sense. Let's run it. Submit it. Sweet. Okay, let's see if we can kind of optimize this. So instead of this, if nums of I is equal to 0, current sum plus equals -1, else this should work. And if I submit this, okay, improves it. Doing that, that's pretty solid. Thanks for watching. See you guys tomorrow.